All right, we're back. I'm going a little crazy. We're working on dilations now. Dilations, different from rotations, of course. Instead of spinning around, we have an excellent diorama here. We're going to be growing. So a dilation is a reduction or let's see, what word do they even use? Inflation? Enlargement. Okay, sure. We have an enlargement. Of a figure with respect to a fixed point called the, you know what, I'm kind of guessing here, point of dilation. I think that is going to nail it good enough. A dilation is an example of a blank blank in that it does not preserve congruency. Okay, so I'm thinking we're not going to have congruent shapes anymore. We're going to have a similar shape. And so let's call it a similar transformation. Honestly, still kind of guessing with that one, but it's got to be right. A dilation produces blank blank. Not really sure what they want there. All corresponding angles are congruent and all corresponding sides are proportional. Of course, we got the scale factor, which we're using k. And so if k is greater than 1, we're going to be enlarging. Enlargement. Sure. And if k is less than 1, this is going to be a reduction. Obviously, right? If k is 1/2, we're going to be in half as big. Now, the good news is the dilation rule is the pre-image of the point, then its image after dilation, and it's in order. Super easy. Oh, there's supposed to be a rule here. I believe it's just kx comma ky. Cross your fingers. We got it. I don't even have that on here. Disappointment. Okay. Kx, ky, aka just multiply by k. Simple as that. So, starting off here, we've got our triangle, RST, -5. Oh my god, we got a different size grid. I gotta count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, they're 10 big now. 1, 2, 3, 4, 5, 1. -5, 1. That is R. Then we've got -3, 4. That is going to be S. And then we've got +2, -1. That is going to be T. And when we're doing these, K is equal to 2, obviously very important. We're basically just going to be getting twice as big of a shape. And the way you want to think about this is that your coordinate is going to go twice as far away from the origin as it was. So if you think about this T here as being, maybe you think about it being 2 boxes over and 1 box down, we got to double it. We got to get twice as far away. So instead of going 2 boxes over, we got to go 4 boxes over. Instead of going 1 box down, we got to go 2 boxes down. And the good news is that's literally just multiplying by 2. So, same thing here. Parentheses with a comma, parentheses with a comma, parentheses with a comma. And we're going to multiply by 2. So the R is -5, 1. So we're going to go with -10, 2. The S is -3, 4. We're going to go with -6, 8. And the T is going to be 4, -2. We already talked about the T, 4, -2. Easy, that's my T prime. The S is going to be -6, 8. And the R is going to be -10, +2. So now, what we've got... Oh, a little bit ugly there with the Sharpie. Apologies. Good enough. Now what we've got is a black original pre-image that has been enlarged to the blue image. Literally, it's just twice as big. You'll notice that the blue is the black is inside the blue. That's because we had points all around the origin. In the example here, we have points
not around the origin, see the origin's over here, and we're not around the origin, that means that we're going to end up, looking a little bit different in that one. Okay, let's try this one. We got a rectangle. Let's do this really quick. -3, 0. Got it. 1, 2. Got it. 2, 0. Got it. -2, -2. Got it. So easy. Again, we're all around the origin, so when we grow up, we're going to be even bigger. That rectangle is going to be on the inside. And my scale factor is 3, so I need to get 3 times as big. Basically, multiply every number by 3. That's going to be -9, 0. 1, 2 is going to be 3, 6. 2, 0 is going to be 6, 0. -6, -6. Plot these down. -9, 0. Got it. 3, 6 over 3 up 6. Got it. We got 3, 6, 6, 0 over 6 up 0. Easy. -6, -6, -6, -6. Got it. And we draw this. And yeah, it's a rectangle. It's 3 times as big. So easy. Whew. Man, transformations, the easiest thing in the world. Here we go, JKLM. Let's get these down. -10, 2. Got it. -2, 8. Got it. 6, 2. Got it. And -2, -4. -2, -4. Got it. It's a rhombus. It's not a straight line. All right, now we have a K of 1/2. Oh my God, we're going to have to get half as big. I hope they use the even numbers so that we can cut them in half. Otherwise, we're going to get fractions. The good news is they're all even. So J is going to be 1/2 and 1/2. Easy. K, 1/2 and 1/2. L, 1/2 and 1/2. 1/2 and 1/2. So easy. Plot them down. -5, 1, 2, 3, 4, 5, 1. Got it. And K, -1, +4. Got it. And 3, 1. Got it. And -1, -2. Got it. And this rhombus is inside that rhombus, and it's about half as big, and everything is looking fantastic. All right, we have done such a good job so far. Boom, we're on the very last little bit here. A question that says, A prime, that means it's the second one, is the image, which comes after a pre-image, of A after a dilation with a scale factor of 2. What are the coordinates of A? So importantly, remember, this A prime is the result, -10, -8. And I know that we had to multiply by 2 because of the scale factor of 2 to get here. What did we start with? Now, you might be thinking, oh, it's going to be 20 and 16. But remember, we're not trying to go from the start dilated more. We're trying to go from the dilation backwards. So instead of multiplying by 2, we're going to need to divide by 2. Instead of getting twice as big, we need to cut it in half. -5, -4. Same thing here. P prime is the image which has come after the dilation at the origin with a scale factor of 1/3. So you might be thinking, oh my God, I gotta do 5, 1/3 of 5. That is so gross. But you don't. Instead of going 1/3 in this direction, we're going back this direction. How do you do the opposite of multiplying by 1/3? The reciprocal. You multiply by 3. So going back this direction, we should have -6 and 15. Now, if you're ever unsure about this, you now have a straightforward check, right? Does this make sense? -5 times 2 makes -10? Yes. -4 times 2 makes -8? Yes. That -6, 1/3 is -2? Yes. 15, 1/3 is 5? Yes. Everything checks out. We're good to go. Last thing here. Determine the scale factor. Okay, determining the scale factor shouldn't be all that hard. Remember, it has to grow evenly. All of them have to grow evenly, which means we don't need to check D and E and F. They're all the same. So just pick one of them. I'll go ahead and pick D, and I can see that this D is at 0, comma 2, and this one here is at 0, comma 1, 2, 3, 4, 5, 6. So how much did I get multiplied to get from here to here? And there is where I very quickly ran into a little bit of a mistake. I need to compare the D and the D, and I haven't made any mistakes yet. But my scale factor, I can use K for that, I have to make sure that I'm going from the original to the new one. If you remember yesterday, when we did transformations, so which one is the OG D? And which one is the D prime? This is where we started. So if we started at 6 and we ended up at 2, what we did is multiply by 1/3. You can't say divide by 3. It's always a multiply. And so we actually multiplied by 1/3 to get there. Let's do one more. Figure out which one is the OG. This. The small one this time is the OG. And then pick 2 letters. I like to pick easy ones that are close together, ones that are nice and nice numbers, or ones that are right on the 0. Because if they're right on the 0, it's a little bit less for me to think about. So I like X for this question. This is at 2, 0, and this is at 1, 2, 3, 4, 5, 6, 7. They switched back to the 8 on me to try to trick me. 2, 0, 8, 0. How much did we have to multiply to start at 2 and finish at 8? We had to multiply by 4. And these should be the same for all of them. Z is -1, -1. K is, I'm absolutely going crazy. -4, -4. We had to multiply by 4 to get there. Done. All right, dilations, so easy. We did reflections a second ago, and I'm going crazy. Also, not that bad, but we had to memorize those things. But the good news is, open notes. So take good notes, and you'll be good to go. Nice.